Hi folks, CodeTutor here and my name is Anil Deshpande. Hi folks, welcome to the another video on how to refactor code to achieve solid principles. In the previous video, we have seen how to refactor the code to achieve open and closed principle. And as we refactored our code, we almost ended with around 28 classes after refactoring for the open and closed principle. And before that, we have refactored for single responsibility principle as well. Yes is done, O is done. The next one that we have to do is Liskov Substitution Principle, that is LSP. So let's start with the same code base where we have code which is compliant with OCP and start refactoring it as per the Liskov substitution principle. So what is the Liskov substitution principle? It basically says object of the superclass should be replaceable with subclass without affecting the functionality of the program. So let's examine the code base of the college management system. We are already familiar with this. We have been going through this since last couple of videos. What we will do is we will identify the classes which violate the Liskov substitution principle and refactor the code to resolve them. So here is our code base of all our application. The code that we are looking at is classes that are present under the integrated package. So let's look at student class. So what do we have here? We have a class called student. It is an abstract class and there are various other subclasses, postgraduate student, PhD student, lot of things. But here there is one postdoc student which overrides get course type but throws unsupported operation exception. This basically violates the LSP because postdoc student cannot be used in place of student if get course type is expected to return a valid string. This can cause a runtime error when postdoc student instance is used in context where get course type is called, as it breaks the expected behavior of the student class. Now, how do we refactor this particular code? The only way is we have to move this particular get course type function out of this particular abstract class. And if we are going to get out of the abstract class, we can make it as a part of some kind of a interface. So what we will do is we will create a interface called as course type provider. We will move this abstract function here under this interface. You can get rid of that abstract keyword. It is redundant here. And now this undergraduate student can extend student and also implement course type provider. And you can still have the overriding functionality of get course type. So wherever you need this get course type and makes sense, you can add it here. But here in this case, postdoc student, where you are now throwing unsupported operation exception, you can completely get rid of it. So now this code is complying with Liskov substitution principle. Let's have a look at another such class. We have staff.kt, and once again here it is an abstract class. There are two abstract functions here, that is get salary and engage students. All the subclasses, that is academic staff, non-academic staff, all are overriding get salary and engage student functions. But then there is this class called as visiting staff which overrides get salary but then also throws unsupported operation exception with a error message saying that visiting staff do not get a regular salary. They are paid per visit. This basically means I cannot use visiting staff in place of staff because get salary will throw a exception. This will cause runtime errors as it breaks the expected behavior of the staff class. So once again, how do we refactor this? We basically create an interface and move this problematic function into that particular interface. So let me create a interface here. Let me call it as salary receiving staff, and in that let me move this abstract function get salary, and then all the stuff which need this implementation will have to also implement salary receiving staff interface. Let me continue doing that. Here also I need it. And in case of visiting staff, I don't need it because that is not a salary receiving staff. So I can just get rid of it. So it just makes it very easy to refactor this particular code and avoid the situation where I can't substitute one class, that is subclass, with a parent class. Then we have this course. This course has function called getTenure, and all these subclasses will have to return some kind of a tenure if they extend course class. Undergraduate course has a tenure, postgraduate course has got a tenure. PhD courses and postdoc courses don't have any tenure. But because they are extending course abstract class, they will have to give the implementation of this abstract getTenure, but then still throw a exception. This is once again another violation of LSP, because I cannot replace course with PhD course or course with a postdoc course, because this will throw a runtime exception in a unsuspecting code. Now, what is the solution? Once again, refactor it. We will go to the top here. We will create a interface. Let me call it as tenure provider and move this into this interface. And now, wherever you need a tenure, I will implement that particular interface. Postgraduate also needs, so let me add that. PhD course don't need it, so I will just simply get rid of it. I will not implement the tenure provider interface. So now we have basically removed all the violations of LSP in our code. If you are wondering how many new classes are there in our new structure, if you do the counting, you will end up with almost 32 classes. This is basically after Liskov substitution refactoring. And before we did that, as per the OCP, how many classes were there? If you go back to the previous video, we had almost around I think 28 classes. So the number of classes are increasing. So this is very important thing to keep in the mind. Okay, now our code is compliant with single responsibility principle, open and close principle, and Liskov substitution principle. All these are now taken care. That doesn't mean our code is still compliant with the very next principle, which is interface segregation principle. This we shall see in the next video. So stay tuned for the next video where we will refactor our code to satisfy interface segregation principle. Thank you for watching. Brings us to the end of this particular video. Don't forget to like, comment, share the video and subscribe to the channel. Take care. Bye.